Hello guys, welcome back to my class. In the past lessons, you have learned different variables that form from different data types, such as integer, string, char, float, and double. In these lessons, I will show you another special variable here known as pointer. But before we go into detail what is pointer, so let's understand first how a variable works. Okay, when you are creating a variable, declaring a variable, okay, then when you assign this value into this variable, all right, this value here will be stored inside a space, and each space here has its own address. We know it as memory address located in PC memory. Just like everyone here, we have our own house, we have a place to stay, and each house here we have an unique address. Same like the variables, they are staying in some space, and this space here has own memory address. So in C++, in order to retrieve the memory address of the particular variable, you have to add this ampersand symbol in front of a variable name. Okay, so here is the example. We have the two values. You assign this 21 into this value 1, 65 into this value 2. So basically they are storing inside a different space with different memory address. So in order to retrieve the memory address, to find out what is the address, you have to add this ampersand symbol in front of the variable name. So I run it. It will show you the memory address. Okay, so it's quite complicated here. So in this lesson, I will just simplify the address like as 0001, 0002 instead of this so long address. Okay, I just simplify as 001 and 0002. Now let's move on to the new variable today, pointer. By definition, the pointer is a variable whose value is the address of another variable. Okay, I repeat, this pointer is actually storing the address of another variable. Okay, make sure you understand the meaning first. Is the variable that the value is basically the address of another variable. All right, so for instance, in this you are creating this value 1, the variable name value 1, storing a value of 21, and this value is storing inside this memory address 0001. Okay, when you are creating a pointer, okay, and point to this variable, it is basically storing. Okay, you see the value here, the value of this pointer is basically a address for this value 1, for this variable. Alright, so I repeat, this pointer is basically storing the address of another variable. Okay, so basically this pointer has its own address also, but in this case we don't really care about the memory address for this pointer. What we care is the value. The value for this pointer is basically the address of another variable. Okay, so here is the example. So I have this variable 10, and I have a pointer is pointing to this x. Don't worry about this a person, this stuff first. So you know the concept first. Okay, you have a pointer which is pointing to this x variables. Okay, so I run the program. You will see both of them are same, because you add a person here is actually to retrieve the address. The address of x is basically this 0x etc. and 44. So you have this pointer is pointing to this x. So remember, what is the definition of a pointer? It's basically storing the value of this pointer is storing the address of other variable. So when you retrieve this value of this pointer, it will show you the address of this variable x. Okay, now let's see how to declare this pointer. Pointer is a type of variable, so we need to declare also just like other variable, but there are some rules. or syntax that you have to follow to declare this pointer. The first one, you have to add this star symbol. Okay, you have to add this star symbol in front of your pointer variable. Okay, the second rules here is the pointer here can only point to the variable of the same data type. Okay, in the previous case, the variable is in the integer type, and we create this pointer that point to this variable. If this variable that being pointed to is in integer data type, so when you are declaring this pointer, you have to follow the same data type. For instance, integer. Okay, there are two rules. One is you have to add this star before the pointer name. The second one, you have to add the data type, and this data type must follow the variable that you are going to point to. Okay, so if the variable that you are going to point to is in double, so you have to put this double, put a star here in front of this pointer name. Okay, if the pointer that if the variable that you are pointed to is in the char data type, so you have to make it as char. Okay, so when you declare this pointer, this star actually can appear anywhere between the type and also your pointer name. Yes, for instance, although you have a space here, yes, it's valid. Although you have a space before this pointer name, yes, it's valid. Or although you have this space before and after the star symbol, yes, it is valid also. But in example 4, okay, so this P is a pointer but Q is not pointer because there is no star in between integer, your data type, and the this variable name. Okay, so basically this is how it looks like. When you have this integer star PQ, okay, it's basically integer star P and integer Q. Yes, so this is a pointer. Okay, so this is a pointer. This is not a pointer because there is no star in between. Okay, so meanwhile for the case number in order to improve this, let's say you want to have this P and Q also pointer, then you have to add this star, okay, which is integer star P star Q. Yes, then your P and Q are pointer now. Now I will show you how to assign the value to a pointer. Okay, as I mentioned earlier, pointer is used to store an address of other variables. Therefore, we need this address operator at %. Okay, so we need this address to be stored into the pointer. Alright, so here is the step. We have two methods to assign a value to a pointer. This is the method 1. Firstly, you have this 10 inside this variable x. Okay, then this is how it looks like. When you declare this x equal to 10, a variable here will be created having this address 0001 with the value of 10. Okay, next step, when you declare this pointer, so this is pointer declaration, int, you have a star ptr, so this is how it looks like. Another pointer will be created, has its own address, but as I mentioned, the address for the pointer is not important at all. Okay, what we care is how do we store the address into this pointer. So this is how we add this ampersand in front of the x. So we are assigning this address into this pointer ptr. Therefore, the value for this pointer is equal to 0001, having the same address of this variable x. This is the first method. Okay, else you can straight away assign the address into this pointer. They are having the same effect, same output. Okay, just now from the method what you have two lines. You declare first, then only you assign. But in this method too, you can straight away assign into this pointer. Okay, so you may ask, what is the purpose that we declare this pointer? Why we need this pointer variable to store an address for another variable? So I will explain to you what is so special about this pointer from this side onwards. An interesting property of this pointer is that can be used to access the value of the variable that pointed to. Okay, since this pointer is having the same address as the variable that pointed to, so basically they are sharing the same content. Okay, for instance, you have a variable here 0001 equal to 10. Okay, if let's say we create this pointer, we are pointing to this address. Okay, so since they are sharing this same address value here 0001, therefore the content, we say that the content for this pointer will having the same value, which is 10. Okay, so in the pointer, how do we retrieve the content? We know it as a dereferencing operator. Dereferencing is a process to retrieve the content of this address 0001. Okay, since they are having the same address, so definitely they will be having the same content. Okay, in this variable we call it as a value 10, address 0001. But in pointer, the value for this pointer will be the address for this variable 0001. Meanwhile, the reference value or the reference content for this pointer will be equal to 10. Okay, look at this example. We have this x equal to 10. This is the variable. So we have a pointer. It's pointing to this x. Okay, so what will be the value of x? You have 10, right? How about the address? The address of this variable. We have to add this ampersand symbol in front of this variable to retrieve the address. Alright, so how about the value? The value of this p. The value of this p is actually the address, right? It's actually the address of the x also. Okay, how about the content? The content for this pointer, we call it as the reference content, the reference value. Okay, we dereference this pointer and we will get the content of x, because the address of this pointer and the address of these variables is the same. Since they are having the same address, therefore they will be having the same content also, which is 10. So if I run the program, this is how I get, okay, content of x 10. The address and the value for this pointer is the same. Since they are having the same address, therefore the content of the p is the same as the variable x. Okay, so bear in mind, this int star ptr is not equal to this star ptr. Okay, when you have this integer, this data type and the star in front of the pointer, we call it as a declaration. Okay, pointer declaration. When you have only star in front of this pointer, we call it as a dereferencing operator. We retrieve the content. We retrieve the content of this pointer. Alright. So bear in mind, there are a lot of students that are making the same mistake, where they don't really differentiate what is the dereferencing operator and also the pointer declarations. Now I will show you what's so special about the pointer, why we need to retrieve the content. Okay, so given these situations, okay, we have this variable a, address 0001, value 7. Okay, then we declare the pointer point to this variable a, and this pointer is having the same value, which is the address 0001, right? So we dereference this pointer, we will get 7. Okay, because they are having the same address, therefore the content of this pointer is same as this value for this variable a. Okay, now if let's say I change the content for this pointer to 10, I assign this 10 into this pointer, into this content of this pointer. So this is how it looks like. So I change it to 10. Okay, so what happened next? Since they are having the same address, if I change the content for this pointer, so automatically the variable a here, the value for this variable a here will be changed also, because they are having the same address. So this is the powerful thing about a pointer. Okay, look at these examples. So what is the output for this value 1 and value 2? Okay, so I run the program first. We have this value 1. Given this value 1, we have this address 0001. Okay, the value of 5. We have this value 2, 0002. We have value 15. Then look at this lines 8. We are using this pointer ones pointing to this value ones. Okay, we are pointing to this P1. So the value is same, therefore having the same content 5. So this is P2 pointing to this value 2. So therefore having the same address and the content. So basically this is the star P1, this is the star P2. Okay, so now move on to line 10. You assign 10 to this P1, means that you are going to assign 10 to this P1. So since the content for this P1 is 10, therefore the value for this value 1 will be changed to 10 also, because they are having the same address. Okay, now move to the line 11. You are assigning the content P1 to content P2. Content P1 is equal to 10, therefore your content P2 is equal to 10 also, because line 11 we are assigning this content of P1 to P2, therefore the content of P2 is having the value of 10 also. Since this P2 and this value 2 are having the same address, therefore it will change the content in the value 2 also. It will change to 10. Okay, this is line 12. Okay, this is line 11. Okay, now move to the line 12. P2 equal to P1 means that you are assigning the address of this P2 to P1. So what is the address of this P2? 0002. You are assigned to this P1. So this is going to be your 0002. Okay, so this is output for line 12. Now move on to the line 13. You assign 20 to the content of the P1. So content of P1 is equivalent to 20. Okay, so therefore since P1 and P2 are having the same address, so it will change to 20 also. And since value 2 and P2 are having the same address, so it will change to 20 also. Okay, so finally what is the output for value 1 divided by value 2? So the value 1 is equal to 10, value 2 equal to 20. Okay, your output will be 10, 20. Okay, clear? In the previous case, we know which variable a pointer should point to, right? Just like this. Okay, we know that this pointer is going to point to this a variable a, so we assign the address to this pointer a. But in some cases, we don't know which variable that we should point to at the beginning. Okay, so in this case, we have to initialize the pointer to a noun, null, means nothing. We point nothing first. Okay, it is always a good practice to assign the pointer noun to the pointer variable in case you don't have this exact address to be assigned to this pointer. Okay, so this is done at the time of variable declarations. A pointer that is assigned now is called as a noun pointer if you don't have an address to assign to this pointer at the beginning. Okay, if let's say you didn't assign this null to this pointer, okay, then this pointer may just point to existing variable which has been using, or pointing to the memory used by the operating system. Right, so you will just simply point this pointer to whatever variables in the memory. So to avoid this, it is a good practice. You always assign this null to this pointer first. If let's say you don't have the address to assign to this p at the beginning. Okay, and here is the example how we declare a pointer to nothing. So look at this example. You have this integer 1, value 1. Okay, 0, 0, 0, 1 having the value of 5, and value 2, 0, 0, 0, 2, value of 15. Okay, so then you create a pointer known as a my pointer. It's point to nothing. Okay, null point to nothing. So therefore, the value is, there's no value, there's no content. Okay, there's no content for this pointer at this moment. So now you go to the line 10. Yes, you're pointing this pointer to this value once. So point. So you're having the same address now. Now line 11, you assign 10 to this pointer. So you change the value to the 10. Therefore, this value 1 and my pointer having the same address. Therefore, the content for this value 1 we change to 10 also. Okay, now line 13. Okay, so you repoint this my pointer to the value 2. So you break this pointer. Now it point to this value 2. Since it's point to this value 2, the address will be changed to 0002 also. Okay, and also it will change the content to 15. This is the effect of line 13. Now move to line 14. You assign 20 to this content for the my pointer. So you change it to 20. Okay, so what happened next? This also will change because they are sharing the same address. My pointer and value 2 having the same address. So this one will have the value of 20. So your output value 1 divided by value 2 will have 10 divided by 2. This is your answer. Okay, so one of the very important use of this pointer is to store the address of dynamic variables. A dynamic variable is a variable whose address is determined when the program is running. In the previously we just store the static variable, store the address for a static variable. Okay, static variable is a variable that has a memory reserved for during this compilation time. Meanwhile, this dynamic variable is the variable that address is determined when the program is running. Okay, therefore there will be no name for this dynamic variable. It's nameless, no name for this dynamic variable. So there's no name. So how to manipulate the value for all these dynamic variables? So in order to solve this, we can actually manipulate or retrieve the value for this dynamic variable using the pointer. Okay, so here is the example of the pointer that point to the dynamic variables. Okay, so the operator new new is used to create a nameless dynamic variable. Okay, So with the data type, in this example, okay, we are creating this dynamic variable having the data type integer, no name, nameless one, that for dynamic variables. Okay, so now we are creating a pointer to point to this dynamic variables p. Since this dynamic variable having the same having this integer data type, therefore when we declare this pointer, we have to follow the data type also, int, integer. Okay, so I'm going to show you how the sample code on how the pointer actually point to this dynamic variable and manipulate the value. So look at this slide. Okay, yeah, so look at this slide. Okay, we have two pointer, p1 and p2. Okay, when you have this p1 and p2, we are creating two pointers here. Okay, and p1 is pointing to this dynamic variable, no name one, therefore there's no name, nameless, and this dynamic variable is having the integer data type. Alright, okay, now move to the next step. Okay, we are assigning this 42 to this content of the p1, pointer 1. Therefore, since this p1 is having the same address with this dynamic variable, therefore this dynamic variable will have the same value of 42 also. Okay, now next step, assign p1 to p2, means that we are assigning this address of this p1 to the p2. Okay, since this p1 is pointing to this dynamic, therefore p2 also pointing to this same dynamic variables. Therefore, all of them now, p1, p2 and this dynamic variable are having the same content, 42, value of 42. Okay, now move to the next line. Okay, star p2 equal to 53. You are assigning this 53 to the content of p2. Okay, since you are assigning this 53 to this content of p2, and all of them are having the same address, therefore all of them now having the same value of 53. Alright, so now move to the next command, p1. Now you are pointing this p1 to another new dynamic variable having a different address. Okay, so they are independent now. Now you are assigning 88 to this pointer p1. Therefore, this p1 is having this value of 88, and the content of p2 is having the value of 53. Okay, so this new is basically a dynamic variable. So since this is a nameless, no name, so how do we manipulate? So we need the pointer to help us to manipulate, to point to this dynamic variable. Okay. So basically you can perform the arithmetic operations on a pointer also, just like you can do it on a numeric value, such as a plus, or minus, subtraction, additions, increment, decrement, assignment. Okay, in pointer arithmetic, the most important thing that you need to take note is the size of the data type. Okay, the size of the data type. So how to determine the size of the data type? Okay, you can just go to the Google. Okay, you just type size of the data type C++. Okay, you can just go to this website. It will show you the size for integer is equivalent to 4 bytes, float 4 bytes, double 8 bytes. Okay, char is 1 byte. Alright, so come back to here. So each time the pointer increment by 1, it means that it points to the memory location of the next element of its base type. Okay, for instance, just now you see that, look at this, look at this table, integer is 4 byte, char is 1 byte. If let's say you increase the pointer, integer pointer by 1, it means that actually you are increasing the 4 bytes. You are increasing the address, not the content. Remember, what is the definition of a pointer? Pointer is the whose value is actually storing the address. Therefore, when you increase 1 for this pointer, it's basically increase the address for this pointer, not the content. Okay, so since the integer is 4 bytes, so it will increase 4. Meanwhile, let's say you are pointing, you're having this pointer is pointed to this char, so it will increase 1 byte. Okay, increase 1 byte. So this is how it looks like when you're having the pointer. For instance, 0x64. When you add 1, if let's say your pointer is integer, so it's basically at 4 bytes. This is 4 bytes. So 0x64 is the address. You plus 4, you will get 0x68. Okay, so I will show you here the example. Okay, look at this. You have this number 7. Okay, you are pointing to this number. So they are having the same data type, which is integer. Now you see out, okay, PNPTR, this is actually to read out the address. You are going to read the address, not the content. If you want to read the content, you have to add the star in front of this pointer name. Okay, since you are just putting this at the pointer name, so it will just display you the address. Okay, it will show you the address. It's 9B4. So you plus 1 means that you're going to add 1 to this address. Okay, so since integer is 4 bytes, so you add 4. 4 become 8. Add 2 means add another 4 again. You become C. C is actually 12 in hexadecimal. In different numbering system, in hexadecimal. So C is actually 12. 12 plus 4 bytes again, you will get 16, which is equal to 0. Add 1 into this B, becomes C. Okay. So this is other example. Suppose we have the char, short and long. So we increase all this pointer by 1, see what will happen. Okay, imagine that you are having this address, memory address 1000 for this char. So you just add 1 because 1 byte. Short is short is 2 bytes. Okay, so short is 2 bytes. So if let's say your current address is 2000, so you just add 2. So how about long? Okay, long is 4 bytes, so you just add 1 for 4 bytes. Okay, so here is the example. You can try yourself and comment the answer in the comment box below. Now let's move on to the last part of this pointer, which is reference variable. A reference variable is an alias or an alternate name to an existing variable. The effect of this reference variable is just same like the pointer, just the way they declare is a bit different. Okay, so in order to declare this reference variables, you have to add this ampersand sign in between the reference variable name and your data type. Okay, and the data type here must be the same as your variable that you reference to. Okay, if you declare this reference, it means that this new name is a reference to existing name, or this new name is an alias of this existing name. Okay, so this is how it works. Let's say I create a variable number 88. So this number 88 will have the on address value, right? For instance, 068C, and its value is 88. So when we declare this reference, okay, for instance, int, okay, ampersand reference number, this is your reference variable name. You refer to this number. Okay, when you refer to this number, basically you just create an alias. Okay, having the same address, exactly same address. Therefore, since they are having the same address, therefore they will have the same value 88. Okay, so bear in mind this ampersand here for the declaration is not equal to the ampersand that you learned just now. Okay, the ampersand, if let's say you just put ampersand and your variable name, is basically to retrieve the address. If let's say you add this data type and ampersand, it's basically you are declaring a reference variable to an existing variable. Okay, so let's look at this example. We have a number 88, so we create a reference. So when you create this value, this reference, all right, so specifically they are having the same address and the value, just a duplicate, a copy, another copy of this variables. Okay, now cout number. So the value for this number is 88. So the value for this reference number equal to 88 also. So in this reference variable, you don't need to put the star here. In the pointer, you need to put the star to reference the pointer, but in the reference variable, no. Okay, you just put the reference variable name, so it will just show you the value is equal to 88 because they are having the same address. So now you assign this 99 to this reference number, so it will change to this 88 to 99. So since both of them are having the same address, so it will change the value inside the existing variable also. Okay, the effect is same like the pointer. Okay, so equal to 99. So now I assign this 55 to the number, the original variable. Okay, I change to 55, and also since they're having the same address, so it will change the content or the value for this reference variable also. Okay, so just like a copy paste. Okay, that's all for today's lessons. I hope you have benefit from this chapter. I hope that you can do revisions. Make sure that you are very clear about this pointer and also this reference variable first before we moving on to the next chapter, which is user defined function. In the next chapter, we are going to use the knowledge from this pointer and the reference variable in some certain subtopic. Okay, so make sure that you are very clear, you are familiar with this subtopic first, this pointer and the reference variable before you go to the next chapter. So I will see you in the next lessons. Bye.